volume is going to be in centimeters cubed, but this could change. Like sometimes they do grams per milliliter, and it just depends on the problem that you're doing. So in shorthand here is that density, D, is mass over volume. To find the mass, you take the density and you multiply it by volume. So they give you the density. Okay, 19.3. Now this is a little different. You do put the units in grams per cubic centimeter. I like to actually put units in brackets to really differentiate them from the rest of the problem.
Okay.
And then volume, you're supposed to assume that this is a prism on the right here. How do you find the volume of a prism?
Height, base times height times length.
Yeah, now remind me, are you allowed to use a calculator?
Yes.
Okay, so go ahead and calculate the volume of this prism for us, please.
All right. Okay. That would be 7 times 3.625 times 1.75, which would give me 44.4.
Yeah, no, there's maybe a question
44.41.
Yeah, you can go out a couple of decimal places here. We'll do like you just said, we'll go out 2 of them. And the units here, what are the units of volume in this example?
Centimeters
Cubed.
Centimeters cubed.
Yeah. Okay. Now, we have everything we need. The density is, the mass is density times volume. So you're going to take this 19.3 and multiply it by the 44.61. Now notice the units though. Do you see how the centimeters cubed cancel?
So yeah, it would just be in grams.
It would just be in grams. That's what it says. And that's kind of a good check. Kind of, they call it a sanity check to make sure your answer is in line here. So it does say to round to the nearest gram, the ones place. So give me your final answer here.
861.5 grams.
So to the nearest gram means the ones place. That means no decimals.
Oh, it would be 86.2 grams.
You're off here. Give me 19.3 times 44.61, and then you're going to round that number.
0.3 times 44.61.
So here's what
861
that's
grams.
right. 861 grams. Okay. Any questions on that?
No, not really.
Okay.
I just got to remember the formula and it'll be pretty easy.
All right. We should do, well, what's on, that's the only, they give you another, we'll do the another, but that's the only, it's the only density problems on here. So, maybe they're just trying to.
Yeah, and then we also had scale factor today. I forgot about that.
Yeah, scale factors are more geometry-ish. So the density of water is 1,000 kilograms per cubic meter. So sometimes it's good to write that number with the units, kilograms per cubic meter, like this. Find the mass of 1 cubic foot of water. And they're saying, hey, don't forget here, we're going to give you the conversion. All right. So any idea what to do here? How to proceed? It's really just a units conversion problem.
Just convert meters into feet.
So if you're calling chemistry, you when you could do a conversion, it depends on what we're trying to convert here. So we want to do we want to find the kilograms per foot cubed. So that this M is going to go up on the top and feet's going to go on the bottom. So it's 1 foot 0.3048 meters. But to cancel with the meters down here in the bottom, you have to cube the top and the bottom.
Cube it?
Yeah, because you need to get meters cubed.
Oh, okay.
Okay, so the cancellation here is that when you cube it, you get meters cubed, they cancel. And then you
Oh,
get
okay.
feet
So
cubed
I
on the
don't need
bottom.
to actually cube it.
Well, you do have to cube the number.
Cube the number.
Yes, but
Okay,
not
so
the, and you're cubing the feet and the one, but one cubed is 1.
3048 and cubed. 3048. 28,360.
Wait, hang on. Wait, hang on. So your answer, like you got the right thing on your calculator. 28 point, right? Decimal point. Not a comma. Not a comma. And it doesn't say what to round to. Let's just round to 1 decimal place. What would it be? 28.3. And the units here are kilograms per foot cubed. Kilograms per
Okay.
foot cubed. And that's the mass. The mass is in kilograms. And that's foot cubed, cubic foot.
So it would be 28.3 kilograms per foot.
Cubed, yes, cubic foot.
Okay. Okay, that makes sense, actually.
Okay. So yeah, it looks like you guys did start talking about scale factors. You should have talked about them before you went to volumes for lengths and then areas. Did you guys talk about that?
No, we actually didn't. We went to that first. The
Okay.
volumes.
Because there's kind of some important stuff here that I'd like to briefly lead into. So let's say I give you a rectangle that's 4 by 6. And then let's say the scale factor is k equals 3. What are the new sides?
It would be 12 to 18.
Good. So let's calculate a few things. Let's calculate the perimeter and the area of the original, and then the perimeter and the area of the next one.
Okay, so the original be 20.
For perimeter.
Yep.
Okay.
And then the area of the original would be 24.
Good.
And then the other one would be 60 for the perimeter.
Okay.
And then it would be 216 for the area.
Okay, so now I want you to take 60 and divide it by 20, and
That'd be
216
3
divided
for the 3, and then 216 divided by 24 would be 9.
be 9. So how do you get 3? How do you get this 3 from 3, the scale factor?
3 to 1 ratio.
Well, it's just itself, like the ratio itself. Now, how about the area from 3?
The area of it.
How do you get this 9 from 3? What's a math operation you could do?
Square root.
The other way, the other one.
Oh, square.
Square. Good. Okay. Now we're going to add a little wrinkle to this. Let's say we now made these 3-dimensional. This is 2. What would this one be?
It would have to be 6.
Okay. So now I want you to calculate the volume of each.
Okay. So 4 times 6 times 3 would equal. Original would be 72.
Okay. The new one.
So times 18 times 6. And the new one would be 1,296.
Okay. Now take 1,296 and divide it by 72.
1,296 divided by 72 would be 18.
There's an error there then. It should be 27. So 12 times 18 times 6. Is that what you have? I wasn't
12
checking.
times 18 times 6, 1,296. 1,296 divided by 72. 18.
4 times 6. Okay, so the issue is this is 48. This is supposed to be 48.
Where did I go? 4 times 6 times Oh, four. Oh, actually, I actually did another
Okay,
4. Sorry.
so do 1296 divided by 48,
96, 27.
27. So how did I know these in advance? So lengths are like perimeters. Lengths are perimeters and sides. They are always K. Okay, so
Yeah.
like 4 went to 12, that's K. The perimeter went from 20 to 60, that's K. Areas though are K squared.
Okay, so it would be 24 times 9, basically.
Yep. And then volumes are K cubed. And
K cubed.
it goes both directions. Like if you want to go backwards, you divide by K squared, you divide by K cubed, or you multiply by K cubed if you're going forward. Okay. So
I see.
this is why I was asking if this was covered, because it you're doing similarity, but this is where you're going. And you're good enough math student. I think we could cover that real quick. So let's look at, so this is somewhat unrelated. It's somewhat related, but unrelated to what you're doing. But let's look at number 8 now. So to determine if they are similar, if two shapes are similar, everything has to be in the same
An equal
proportion.
ratio.
Yeah, so like 6/8 has to be the same as 8/12, has to be the same as 12/16.
I see. And so to find the scale factor, I need to reduce all those, which would give me
O-
3/4.
Only if they all work. It only has a scale factor if these are all true.
Oh, okay. So I need
And
to reduce all those and see if they're equal.
yes,
So 6 to 8 would be 3/4, and then 2. So, and then
yeah, 3/4, and
mhm,
then
8/12 cannot be reduced to 3/4. So it
that's
would have
right.
to be 2/3, and 12/16 would be 3/4. But
Right.
the
So
2/3 makes it
the
not
answer,
similar.
that's right. So are the pyramids similar? The answer is no.
Hmm.
You'll see this often mistaken or confused in kind of real life. The purest sense similar means they have the same ratio. So if they're not, this does not apply.
Okay.
So what would this 12 have to be for it to be similar?
It would have to.
Assume that's 8.
Okay, so
Actually,
it would be.
I'm sorry, that's the wrong one for you to do.
It
Assume
would have to change 8 into
let's change 8.
instead.
What would we change 8 into?
It would have to be 9.
9. Very good. Okay. Now let's do the volume of the little one. So the volume of the little one is the area of the base, okay, which happens to be a triangle,
Hmm.
times its height, okay, and then it's a pyramid, so it's a third. Have we covered this?
Yeah, I think we have.
Okay, if not, just let me know. So it's the area of a pyramid is 1/3 the area of the base times the height. So
Mhm.
the area of the base is the triangle. So it's 1/2 6 times 9, a
Mhm.
third of that times the 12.
Okay. So first I would do 6 times 9, which would leave me 54. I cut that in half, which would leave me with 27. And I do 27 divided by 3, which would leave me with 9. And I do 9 times 12, which would leave me with, I believe, 108.
Yes, so 108. Okay, very good. Now, what is this? Let's just say this was right now. What would this? So we're going from 6 to 8, and then the question is, how do you go from 6 to 8? Or if you don't like that one, how do you go from 9 to 12? You need to figure out the multiplier here.
Okay, it would be 1/3. Right. Wait, no, 1. Oh, yeah. 3, 6, 9, 12.
What do you
Would
multiply
I be
6 by
adding?
to get 8? I mean, it's obviously bigger than 1, but it is a fraction. I mean, it's a little bit
Yeah,
tougher.
I'm up. So 2, 4, 6. And then it would need another 2. That'd be 1/3. It'd be 1.33.
So I heard 4/3. We're gonna use
Yeah.
So let's just say it's 4/3. So if we're going from volume of the first one to volume of the second, and K is 4/3, we should be able to cube that, okay, which is 64 over 27, multiply 108 by 64 over 27 to get the volume, okay? Does that make sense?
Yeah, it does.
Okay, so 108 times 64 over 27, it is nice, it's 256. So now let's do it by hand and see that it is the same. So 1/3, and then the area of the base is 1/2 8 times 12 times 16. So does this equal 256?
Yes.
It does. Okay, so the scale factor is really powerful. Saves you a ton of time because you don't have to actually calculate it once you know. It. Okay,
Yes.
so let's see, number nine here. All right, so are these prisms similar? I want you to give me a yes or no. If they are, give me the value of K, please.
Okay. Let's see, so 4 to 6, that would be 2 to 3, 3 to 4.5, 2 to 3, 5 to 7.5, 2 to 3. Yes, it would, yes. And the scale factor would
Oh, let me go
be,
back here. I should have mentioned this. So to find K, you take the second number and divide it by the first number.
oh, okay.
Yeah, I should have mentioned that. So here it would be like
1.5.
yes, or we'll go 3 halves. So 3 halves.
Okay.
So this time, I know. So let's find. I want you to find the volume of the first prism.
And the first prism. Okay, 4, 8, 12, 60.
Okay, now the K is 3 halves. So K cubed is 27 over 8. Do you agree with that?
Yes.
Okay, so you should be able to find the volume of the second prism by taking the other volume and multiplying it by 27 over
Okay,
8.
so I do 60 times 27 over 8. Yeah, 20 times, it'd be 202.5 cubed.
202.5. Yes.
Yeah.
Okay, so now is that the same as 6 times 4.5 times 7.5?
Yes.
It is. Yeah. So it's one of those things where like if you do something long enough, you're eventually like, all right, I'm tired of calculating the volume. I'm just going to use the scale factor. Okay.
Okay, that makes sense.
All right. Now before we do, we're gonna do this really quick here. So let's say I give you 2 cubes. Okay. First cube, 1, 1, 1. Second cube, 3, 3, 3. What's the volume of each?
3, 6. 1 would just be 1, and then the second one would be 27.
So if we take V2 divided by V1, 27 over 1,
It would just be 27.
This is K cubed though, because it's volumes.
Okay, and so to find that, I would need to do 1 times 27 over 1, which would be 27, and that's the same as 3 times 3 times 3.
Well, so what we're saying is 27 equals K cubed. And so to find K, you have to take the cube root of 27.
Oh, okay, and that would be 3.
Yes. So we want to use what I just said there in this problem to answer this. So you've got to find, and you can actually go the other way. You can actually go 1728 over 125.
So I just need to cube those.
No, you have to, you want to take the cube root of that.
Cube root, yeah.
Yes.
Okay, so I do 1728 cube root of That'd be 12 on top.
Okay. And then
1
on the
cube
bottom,
5 cube root 5.
very
12 over
good.
5
Right. So if it really wanted it in the other order, it would be 5
over 12.
over 12.
But it works both ways.
Yes. It depends whether you're going from the larger to the smaller or the smaller to the larger.
Okay.
All right.